We've been talking about testing the first derivative for where it is either 0 or undefined to see the points where we could have a relative maximum or minimum. We haven't seen examples where the first derivative is undefined. So let's take a look at that right now to see an example where a function is defined at a point but not continuous at it because the derivative isn't defined there, and see what's happening in that case. All right, so we're on page 325 of the workbook right now. And the example they want us to take a look at is x plus 2 to the 2/3 power plus 1. So let's take the derivative of f, which is just going to be using the power rule. Well, I suppose the chain rule, but it's pretty boring because the derivative of x plus 2 is just 1. So the first derivative of f is 2/3 times x plus 2 to 2/3 minus 1, which is the negative 1/3 power. And we multiply that, as I say, by the derivative of x plus 2, but that's just 1, so we can forget that. And then the plus 1 here is a constant, so that goes away. And if we want to write this in a slightly different way, we could write it as 2/3 and turn this back into exponential notation or radical notation instead of exponential notation. So the third root of x plus 2. Okay, so let's think about where this graph is increasing or decreasing based on the value of x. So we're multiplying 2/3, so 2/3 is positive. So this derivative is going to be positive whenever this factor is positive, and it's going to be negative whenever this factor is negative. This factor is positive whenever x plus 2 is positive. So f prime of x is greater than 0 when x is greater than negative 2. All right, and this is when it's increasing. F prime of x is less than 0 when x is when x is less than negative 2. When x is less than negative 2, this is a negative quantity. The cube root of a negative number does exist, but it's negative, which makes this whole derivative negative. And this is where it's decreasing. And when x is equal to 2, or equal to negative 2, then this is 0. The cube root of 0 is 0, and 1 divided by 0 is undefined. All right, so f prime of x is undefined when x is equal to negative 2. And I'm not going to graph the function here, but I am going to pop over to Geogebra where I did graph this. And we can see here that it's doing exactly what we predicted that it's doing, that when x is less than negative 2, the function is decreasing because the first derivative is 0. And then here there's a cusp where the derivative is undefined, because if I zoomed in on this point, it wouldn't look like a straight line at all. It would look like, it would look like a V that was getting sharper and sharper as we got closer to it. And then when x is greater than negative 2, the function is increasing again because the first derivative is positive. Okay, so that's how we can investigate a function and think about where its maximums and minimums are based on looking at the first derivative, even when it's not defined at a point. So when the derivative is 0 or when it's undefined, we need to take a close look at those points to investigate whether they're greater or less than the points around them. In the next video, we're going to start talking about the second derivative and how we calculate the second derivative and how the behavior of the second derivative can be seen in graphs as well.